In the last video, we looked at futures, which handle one-off asynchronous events. But Dart provides another data structure called a stream that allows you to listen to multiple future events and handle them from the same place as they unfold over time. An example might be listening to a real-time data source, like the Firebase Firestore database, or maybe a WebSocket connection. It's not just a single event you want to handle, but multiple events in the future. We can create a stream using the stream class from Dart Async, then call its fromIterable constructor to create a stream of 3 events based on the numbers in this list. In this example, the 3 events will be triggered right away, but in the real world, they're often separated by long time intervals. Now that we've created a stream, we can listen to it using its listen method, which takes a callback function as an argument that will be executed for every event that's emitted by the stream. The result of this code is printing out the numbers of 1, 2, and 3. Another way to think of a stream is just a list that unfolds over the dimension of time. In fact, a stream has many of the same methods that you would find on a list. Like map, will take the initial event and map it to a new value. But there is one really important caveat to understand when working with streams, and that's that they can only be listened to one time. At least that's the default behavior anyway. In this case, we have 2 listeners on the same stream, so if we attempt to run this code, it will actually throw an error saying that that stream has already been listened to. If that's not the behavior you're going for, you can turn the stream into what's known as a broadcast stream, which is one that can accept multiple listeners, kind of like how a radio station broadcasts its signal to multiple receivers at the same time. You just have to be there at the right time to listen to it. Now, the other cool thing about streams in Dart is that you can use the async await syntax on them as well. The difference, though, is that you're dealing with multiple values, so you'll treat it as a loop. Use the await keyword in front of a for loop for each value in the stream. The code inside of the braces will execute each time that stream emits a new event. What you've created is an asynchronous for loop, and this can make your code a little bit cleaner compared to setting up callback functions. When it comes to Flutter, you also have dedicated widgets for building the UI based on the value that's emitted from a stream. But the most important thing to understand is that a stream is just a way to handle multiple asynchronous events, which differs from a future which can only handle one asynchronous event.